So here we're still in 1.3. We're talking about now the definitions of what it means to be an even and an odd function. So we'll start by filling in the first two blanks here. A function f is an even function if when you input the opposite of x into the function, you get the same thing as f of x for all x in the domain of f. The right side of the equation of an even function does not change if x is replaced with negative x. The graph of an even function is symmetric with respect to the y-axis. So that means there is symmetry with respect to the y-axis. So if this is my xy axis, an example of an even function would look like this. And so here's a parabola. And if you would fold it on the y-axis, it would have a mirror image. So that has symmetry with respect to the y-axis. Now, the next part here of the function f is an odd function. And the way we know it's an odd function is if you put in the opposite of x as your input, you're going to produce the opposite of the outputs for all x in the domain of f. Every term on the right side of the equation is an odd function, changes its sign if x is replaced with negative x. The graph of an odd function has symmetry with respect to the origin. So let me show you an example of what the graph would look like if it has symmetry with respect to the origin. So here we have a graph. This has symmetry with respect to the origin. If you were to take this graph, so take a look at this graph here, and I flipped it, rotated it 180 degrees, it looks exactly the same. That is symmetry with respect to the origin. So it looks exactly the same if you rotate it 180 degrees, so upside down. So let's look at how, and what they're telling you here, these methods, those are the algebraic way to determine whether the function is even, odd, or neither. So let's look at this with the function h that's given. It says determine whether this function at h of x is equal to x to the fifth plus 1 is even, odd, or neither. So to check if something is even, so I'm going to do this algebraically. You take the function, so here's the function, and you are going to replace x with negative x. So, because we are checking if this is true. So I'm checking if this is true. If this is true, then we're going to say it's even. So I'm going to take the function, and I'm going to, wherever I have an x, I'm going to put in negative x. So this is my original. And now when I put in negative x, let's see what happens. Negative x to the fifth. Negative x to the fifth means you take negative x and you multiply it by itself 5 times. And so when you multiply it by itself 5 times, you're going to produce a negative x. Because this will be positive, then it will change to negative, then it will change to positive, and then at last it will change to negative. So now this is h at negative x. Are the two of these equal? No. we've got x to the fifth plus 1, and here we have negative x to the fifth plus 1. So they are not equal. So then I can say it's not an even function. Now I'm going to check if it's an odd function. To check if it's an odd function, I'm going to take the function. So I'm just going to rewrite the function here. And I'm going to replace x with negative x. And if it's an odd function, then this would be true. Oops. So I already know h at negative x, it looks like this. Right here, where I figured that out. But now I have to find what's the opposite of h. So replacing the x with negative x, I already found this part. I'm just rewriting it here, but I already did that just up above right here. And now I'm going to see what is the opposite of h of x. So the opposite, if I take the function, put a negative sign in front of the rule, all it does is it changes all the terms on the right-hand side to the opposite side. So this is negative h of x, this part here. Does it match the what I highlighted in yellow? It's close, but this is plus 1 and this is minus 1. So then I do not have a match there. And I will also say that these two are not equal. So then it's not odd. So now I've shown it's not even and it's not odd. And if it's not even and it's not odd, then it's neither. So neither is my answer. Now I also mentioned that you could look at the graph too to see if you have an even or odd function. So let's pull this function up on our calculators. So if I want to graph a function, I'm going to hit the y equals key, and I'm going to put in x, caret symbol, 5. Now with this calculator, I have to right arrow over to go down to the normal line. Here's my original function. If I hit graph, I'll see that it looks like this. And it does not have symmetry with respect to the y-axis. So if it does not have symmetry with respect to the y-axis, it's not even. So we don't see a mirror image. Now, this does look similar to what I drew to show you for the respect to the origin. However, if you were to flip this upside down, you would not have the same graph. It would cross the y-axis at -1. So imagine you rotated this 180 degrees. It would look close, but it's not the same. So it does not have symmetry with respect to the origin, and it's not odd. So that's another way that I can approach these problems. Now, if it says to find it algebraically, then you'd want to show it with the algebra. I also want to point out that on the formula sheet, this formula sheet that I'm showing you is available in D2L. It is available under content. This is a formula sheet that you can use on all exams. So at the bottom of the formula sheet, you have the rule for an even function, the rule for an odd function, so that you can apply this. So you don't have to memorize what makes it even or what makes it odd. We just need to show the algebra behind it and then decide if it's even or odd. So let's move on to our next topic. Our next topic is entitled Piecewise Functions. And here's it says our definition: a function that is defined by two or more equations over a specified domain is called a piecewise function. So a piecewise function is made up of two or more pieces. So you've got two parts to your function. Here's an example. This is called evaluating a piecewise function. It says given this function. So we see that we have our function's name is c. C at t is equal to 20 if the input is between 0 and 60. T is our input. So if the input is between 0 and 60, now because I have this less than or equal to sign, it's including the two endpoints. If the input's between this, so if the t value is between these two numbers, then you are going to choose the piece that corresponds. The piece that corresponds is 20. So you're going to choose this as the function to use. If the input is above 60, so if your t value is above 60, then you are going to choose this function. So you're going to choose this one, and you're going to plug t in and get an output. So let's do it for this problem. So it says here, it says evaluate or find c at 40. So I look at the input, 40, and I look to the little rule on the side to the right of our function, and or I guess I shouldn't call it rule, but where I'm going to make the choice. And for 40, it's that falls between 0 and 60, and so that means I'm going to choose this. And so C at 40, there's no t here to put in. C at 40 is simply 20. Now to evaluate C at 80, here's my input now, 80. I'm going to choose this piece, because this piece is for when t is above 60, and t is above 60 here. So what I'm going to do is I'm going to replace t with 80. And then I'm going to put this in my calculator. Put in your calculator, pause the video, see what you get, and then restart it. So you should have got a total of 28 when you put this in the calculator. Remember, order of operations. In our calculator, you can put this in all in one step. If you were going to do it into pieces, you have to do the parentheses first, then multiply by 0.4, and then add 20. So you should get 28. So here we got two ordered pairs. When t is 40, we get an output of 20. And when t is 80, we get an output of 28. So I can write this as ordered pairs, 40, 20, and 80, 28. So let's move on to more discussion of piecewise function on the following page.